This is Nathan with Milestone Scholars today, and today we're going to be talking about types of triangles. So let's get right into it. So the first type of triangle we're going to talk about is a right triangle. So right triangle is a triangle that always has a right angle. So for example, if I have this triangle here, this triangle has a right angle, which means that it is a right triangle. So in the later videos, we're actually going to be talking about two special types of right triangle. One is the 30 degree, 60 degree, 90 degree, which is of course right triangle. So it is called the 30, 60, 90 triangle. And we're also going to be talking about this 45, 45. So this 45, 45, 90 triangle. So that is the gist of what a right triangle is. So we're going to move on to the next triangle, which is an obtuse triangle. So an obtuse triangle is, let me just write this out, obtuse triangle is a triangle that always has one angle larger than 90 degrees. So this angle, as you can see here, is larger, 90 degrees. An obtuse triangle doesn't always necessarily have to have all equal size or all different size. It's an obtuse, actually, it's impossible for it to have all equal size, my bad. You don't always have to have completely different size for obtuse triangles. And this is just a version of an obtuse triangle I'm showing you. You could have one like this, and this would be obtuse because this angle is greater than 90. I'm sorry if my drawing is bad, but yeah. You could also have, for example, if this angle is greater than 90, you could also have an obtuse triangle like that. Um, and that's the idea of an obtuse triangle. Next, we're going to be talking about an acute triangle. Acute triangle. So, one thing that, or one method of remembering the difference between an obtuse and an acute triangle that my old math teacher taught me was that you could see how the word cute is in acute. So so he told us that, or my classmates and me and my classmates, that you could sometimes you associate the word cute with things that are small. So you can associate acute triangles with a triangle where every angle is less than 90 degrees. So this angle is less than 90 degrees, this is less than 90 degrees, this is less than 90 degrees. And as always, again, none of these sides have to always be equal, just like the obtuse triangle. And this is just an illustration that I'm showing you. You could also have an acute triangle like this. You could have all sorts of acute triangles. So next, we are going to talk about we're going to be talking about an isosceles triangle. Isosceles triangle. So what this triangle is, it's quite a special one. Uh, One of my favorites, I would say, honestly. This triangle is where two sides are equal, and two sides must be equal. That's the definition of an isosceles triangle. Basically, two sides must be equal, and a theorem that we're going to be covering later this week is the base angles theorem, and that is involved with isosceles triangles. So if you know that these two sides are equal, then you can also conclude that, let me just draw a different picture. So these two sides are equal. Then you can conclude that these two angles are equal. Now you're not just limited to these two sides being equal. You could have, for example, let's just say these two sides be equal. You could have these two sides be equal. You're not limited to just the pictures that I draw. And for both of these pictures, these two angles, these two angles will both be equal. So that's the gist of an isosceles triangle. Next, we're going to be talking about an equilateral triangle. Equilateral, there is no I in there. Why did I write an I? So, equilateral triangle. What this triangle is a triangle where all three sides are equal. So for example, let's have side A, side B, side C, angle 1, and angle 2, angle 3. So side A would always be congruent to side B, and side B would always, and both of these sides actually would always be congruent to side C. So you can also conclude from an equilateral triangle, since all three sides are equal, then all three angles must also be congruent. So basically, do you guys, I'm actually going to give you guys a moment to think about, what are the measurements of the three angles individually? I'll give you guys a moment while I write this out, so if my board can stop twitching. So angle 1 is congruent to angle 2, which is congruent to angle 3. So, since we know that all angles in a triangle add up to 180 degrees, and since all three of these angles are congruent, we can assume that one of these angles would just equal to 60 degrees, which is 180 divided by 3. So that's the gist, again, of an equilateral triangle. And next we're going to be talking about the scalene triangle, and perhaps the triangle that is the easiest to measure. Well, actually, no, sorry, to remember. Um, a scalene triangle is where the triangle is none of the sides are equal and none of the angles are equal. So for example, I could just have this arbitrary triangle right here, and this side would not be equal to this side, and that would not be equal to this side either. This angle would not be equal to this angle, and that wouldn't be equal to this angle either. So that's the idea of a scalene triangle, really simple. So now that we have all of these triangles, you're probably wondering now, like for example, I could have, I could technically have, um, let's just say an obtuse triangle, and let's just say this obtuse triangle, this triangle right here, this has a measure of 120 degrees. This could be 30. This could be 30. And that'll be an isosceles triangle, and you're absolutely right because it could be an isosceles triangle. All of these triangles are interconnected, and if you really think about it, an equilateral triangle is just a type of an isosceles triangle, if you will, because since three sides are equal, then that just means that two sides must be equal to each other, which means that it's almost like it's like a type of isosceles triangle. Uh, Both acute and obtuse triangles could be scalene because their sides don't always have to be equal. Their sides don't always have to be um not equal. And if you really think about it again, all equilateral triangles are acute triangles. I hope you enjoyed my video today, and thank you so much for watching.